This area contacts the exterior sheathing with only spray foam. This is the only physical contact between the sheathing and the stud.
Why hasn't somebody else thought of this already? It seems smart, but it also seems simple.
And that has caused me a lot of problems across the last couple of years as it...
Listen up, America. This is the American Made Podcast, the show that highlights America's business leaders and experts in all aspects of the manufacturing industry. If it's made in America, you'll find it here.
China. Made in America. Products made with American heart, American sweat.
Now, your host of the American Made Podcast, Jason J. Webb.
What's up, America? It's Jason J. Webb. Today, I am here with Jon Pues, and I got a treat for you guys. It's called EcoSmart. All you manufacturing companies out there, this could be your next big $1 million money maker. And before we get into all that, I want to introduce Jon. Jon, you are the CEO, founder of EcoSmart. Is that right?
Yes, also the inventor.
The inventor. All right. And we had a kind of a long conversation before we got this podcast started. This is quite interesting for several reasons. It's interesting on the construction side of things. I know the Minnesota Made podcast, some of you listeners from that are now listening to American Made, but this definitely has a construction aspect to it. But also on the manufacturing side of things, but Jon is looking for local partners or partners across the United States, it sounds like, to work together with in production of his invention. That makes a lot of sense. It's funny. I don't know. I look at this and I'm like, why hasn't somebody else thought of this already? Right? It seems it's smart, but it also seems simple. You know what I mean, Jon?
And that has caused me a lot of problems across the last couple of years as it's a pretty simple premise.
Yeah. So let me refer to, if you go on YouTube and you can see this, I'm going to reference one of these slides that Jon brought over for me on what this product looks like. So here we got a regular 2x6 that is used for framing material, say in a residential house on the exterior wall. Just a normal 2x6. And then right next to it is Jon's product, the EcoSmart construction stud. And on one side of the stud, you got these notches that are cut out. And each notch, I don't know, what is that, about 10 inches?
Yeah, about 10 inches, 3/4 in depth.
3/4 in depth. And then in the center of the stud, it's a I don't know, like another notch. That's probably another 10 inches. And is that another 3/4 or?
We like to call it the slot. That's 1 inch.
1 inch slot. These slots are spaced apart and there's probably, 3 or so inches, 4, I don't know.
2 inches.
2 inches between each slot. So it's hard to describe if you're just listening to this. Jon, I'm sure you can do a much better job. But if you go on YouTube, and I'll put a link to you have a website, don't you?
Yes.
Yeah, link to the website in the show notes so you can actually see this. And he brought a sample. Can you hold that for me?
Sure.
So you go ahead and do a better job explaining it than what I just did.
Okay, so the idea behind it is this is the exterior of the
Exterior
wall.
of the house, yep.
Exterior of the house.
Exterior
this is the
side
interior.
of the stud, yep.
Yep. And what we want to do is we're limiting the contact with the exterior wall. This area contacts the exterior sheathing with only spray foam. This is the only physical contact between the sheathing and the stud.
And the goal behind all this, by the way, is to increase the R value, the resistance value, the insulation value of the home.
Yes. What we're doing is reducing thermal bridging. And the thermal bridging basically happens through the solid contact of the sheathing on the outside through the framing.
Which is typically what, OSB?
OSB, plywood.
Okay.
There's a lot of new stuff coming down, but basically majority of the market's OSB. So the idea is insulation fills here, for energy to go through that, because it's Minnesota and it's the cold, for that cold to try to come in the house now, it comes in here. Oh, wait a second, I hit the insulation. Oh, now I've got to go this way. Oh, now I can turn this way. We extend that pathway, and it creates a bottleneck here because there's insulation here, there's insulation here. The energy wants to go through its easiest path. We try to limit that path. So now, by disrupting that thermal bridging, this solid 2x6 stud is like an R6, 6.6 to be technically right.
So a typical 2x6 is an R6.
Yep, 6.6. This stud now, depending on what insulation fills it, is upwards of an R16.
Okay.
So we've dramatically increased the R value of the stud, which then reduces the thermal bridging because now the stud is very close to the chamber insulation, which is currently with fiberglass is like R20.
Okay.
So the closer this is to the chamber, the less thermal bridging you have because energy will transfer through the easiest way possible.
Now you mentioned Minnesota. What about hot states?
Works the same way.
For AC savings,
Yep.
energy cost.
Works the same way now. It's just thermodynamics work differently. Everything always wants to go to the greatest temperature. So out in Phoenix where it's 100 degrees, you're trying to cool the inside. The inside's trying to get to 100 degrees. It works, stopping the thermal bridging works the same way.
All right. So to quickly capture the attention of the listeners who are in the manufacturing industry, you have, I don't know, partnered with somebody, a lumber mill or something out in Washington to start production on these. But you'd like to do something similar. And it doesn't necessarily have to be a lumber mill that's listening, but not only do we need the lumber production, but we need the slots and the machining of the 2x4 to be completed. Right?
Correct. Yes. So in essence, this becomes an engineered piece of wood. We have our own stamp for it because we destroy the grade stamp when we start manufacturing it. So what we like to partner up with manufacturing facilities because across the country where this is going to become more prevalent because of the change in the national energy codes, you're talking about hundreds of millions of exterior studs across the country, probably pushing 1 billion exterior studs across the country because we can't use 2x4s as much anymore because the idea of a temperate climate is kind of becoming a novelty. It's like out in Seattle where you heard like they had these heat waves this summer. They literally don't have air conditioning because it always used to be 75 degrees.
Okay.
Now it's 100 degrees. So where they're building new construction, they're taking this into account going, oh yeah, we actually have to start insulating now.
Yeah.
So all across the country, insulating exterior walls is becoming a bigger deal. The attic insulation or insulating the roof is pretty straightforward and relatively simple. It's the walls that get complicated.
Now, what kind of machine would best be used to engineer this 2x4 to your standards?
Well, it's going to be some type of CNC machine, and I just use that term because it's computer numeric calculation. I forget what the third C is, but it's a computer-controlled line that's going to scan the incoming lumber. It's going to send it through multiple steps to get something to come out, to get the stud to come out the other end with as fewest rejects as possible.
Yeah, and it sounds like a big piece to eliminating or minimizing the rejects is to have the quality lumber that's required to do this. I mean, the knots can't be in certain places.
Right.
Right.
They can be in certain places because they get cut out. So it's like we can have knots in these areas all day long.
Yeah.
They're just going to get cut out. But if you're sourcing your lumber directly from the mill, they have the best way to pre-select your lumber. So for production purposes, you'd want to have your plant really close to the mill. Like out in Washington, they're literally across the street from each other, literally.
Yeah. So the right scenario would be you have your lumber mill that can scan the lumber and select the correct lumber that meets the standards of EcoSmart construction studs. And then that lumber is just whatever, driven across the street to the CNC machine,
production facility.
in which they cut the slots. And what part is this right here? That's a slot. And what do you call this?
We'll call that the face profile.
Face profile?
Yeah, the face profile, because you're going to probably end up cutting it two different ways.
I think groove is better.
Okay.
Slot and groove.
That works. I like that. Our production specialist figures that the slot will get cut one way, then you tip it on end and cross cut the other way. That's going to be the most efficient way to do it. And then it all comes down to scale. The more you can produce per minute, or the lumber industry likes to use board foot, which I still don't have my head wrapped around, but that's how they count it. I count it by studs. So the more studs per minute, the lower cost it is for production.
Okay. Now, fast forward a year from now. If I go to, let's say, Home Depot, and I want to buy one of these, do you anticipate these being way more expensive than the typical 2x6?
Not terribly. It's always a tough question to answer because there's so many
Variables.
parties. Yeah, and it's more of the parties involved.
Yeah.
Because it's not, instead of being a commodity item, this is now a value add item.
Yeah.
For the average contractor, you're just buying a stud.
Yeah.
When you're buying this now, you can go, oh, well, you bought this, now you saved X. So for every dollar you spend, you save X amount of dollars. So it's a value add product, because one of the benefits to this is pre-drilled for electrical. Your electrical install goes faster.
Yeah.
Your low voltage install goes faster. Your gas lines go faster. If you're down in Texas, you can fit a water line through there. I don't recommend it, but they do that. In areas where it's warmer, they'll run water lines through exterior walls. We don't do that in Minnesota. Bad idea. But it speeds up the process. So that, again, that's a value to the contractor.
Yeah. Can you think of anything like this compares to currently in the home construction industry? I mean, for some reason, this is probably a bad comparison, but when you're talking about value add, I think of like maintenance-free decking.
Oh, okay.
Right?
Yeah.
Definitely costs more than cedar decking.
Right.
But a lot of people feel it's well worth it because they don't have to, maintain it.
You're saving money on your maintenance.
Yeah. Is there anything else that pops in mind that might be a good comparison to what EcoSmart has here with the studs versus another part of the home? Maybe triple pane windows?
Triple pane windows would be a good example. Solar panels, because when we do our model simulations, because this is so much less expensive than doing rigid foam on the exterior of the house. That's the way the code is gone. The upgrade cost for your average home, 2,600 square feet, maybe about $4,000. You're going to save more money in your electric bill and your gas bill than you're going to spend in your mortgage costs. So the homeowner starts saving money day one. So that's a benefit for the homeowner. The benefit for the contractor, again, is he spends less time on a job. There's a benefit for him. There's a benefit for the framer. It's safer for the framer to use. So there's a lot of built-in benefits for this, because we're trying to make life simpler and take out steps versus adding steps to the construction process that just makes everything more expensive.
So it's safer for the framer?
Yes, because they can actually hold on to it.
Oh, okay. And when using this product, I think earlier you said it eliminates the requirement for rigid foam on the exterior?
Yes, because what the goal of the energy code is, and they stated it pretty plainly in the last iteration in 2021, is what they call the 0+20 wall. So in the 0 means in the chamber. So nothing in the chamber, an R20 on the outside. So R20 continuous insulation, which means they're saying they want the actual value of the wall to be an R20. Okay, cool. Now we know what the number is. When you use these studs and the mix of insulation, and we do the actual calculation, because in days past, it's always what we call stated. It's an R19. That's how everybody's familiar with it. It's like, oh, it's an R19 wall. Well, yeah, no, it isn't. It's R19 for the chamber, the framing's a 6, and the window's a 2.
Oh.
When you do the math, that comes out to 8. That's a big difference from 19 to 8.
Right.
So now they're saying, okay, we're going to actually take that into account. So on the wall, minus the windows, we want it to be an R20. We come out at 20 and a half with 1 inch of spray foam in the chamber. So we have accomplished
without the rigid foam.
Without the rigid foam at far less cost, far less complexity, and you actually build a better wall because now we have spray foam, which is a glue, and nails, which are mechanically fastening the system together. So now you take your pick. Is the glue reinforcing the nails or the nails reinforcing the glue? Our racking value goes from here to up here. You've built a more resilient wall now. So that's another benefit.
So construction costs. So when you factor in, let's just say, I would assume this would be because there's engineered costs, there's manufacturing costs, and then it's high grade lumber versus crap, right? It's that 2x6 is going to cost more than a typical 2x6 you might find in an exterior wall. That's because it's better. But when you factor in the fact, that's my Annandale High School education coming out. When you factor in no exterior rigid foam insulation needs to be purchased or installed, the cost by the construction costs of that wall, I would assume would be less.
Dramatically lower.
Yeah.
Dramatically.
And then you mentioned the homeowner starts saving money right away because their electric bill is lower than it would have been.
Exactly. And because we've kept that cost down.
Mm-hmm.
Because if you keep the cost down, so instead of it being an $11,000 upgrade cost, it's now only a $3,500 upgrade cost. You've now given the homeowner the ability to go, oh, well, that triple pane window upgrade's only another $2,000. Well, let's do that.
Mm-hmm.
So now I've got $5,500 invested. I'm still $6,000 ahead of that $11,000 wall, and I've got a much better wall, and I still got money for granite countertops.
Mm-hmm.
That's where it's a win-win for the homeowner. And for the contractor, easier to build, labor savings. So he just has to decide what he's going to do with the labor savings, and there's less chance of a callback 5 years down the road that there's an issue. Because, again, the spray foam glues everything together. We don't have to worry about any structural compromises. It seals everything up. No air's moving around.
Mm-hmm.
And there's less chance of water getting trapped because that's what happens with rigid foam. This is Minnesota. It gets to be 20 below in the winter and 100 above in the summer. We tend to have moisture issues that pop up really fast. And that's one thing contractors don't want is stuff rotting out around windows because the water gets around the flashing and then gets trapped between the foam and the sheathing.
Mm-hmm.
That's a known issue with using rigid foam on the exterior. Now, in warmer areas of the country, it's not as big a deal. Here in Minnesota, different story.
Yeah, I had an insurance claim with a client back in the day, several years ago, as a chiropractor who was having their windows replaced because the building was old. And in that process of replacing their windows, they discovered basically that whole wall is rotten because water got it down in there. And with insurance policies, unless they're endorsed otherwise, the standard insurance policy excludes workmanship by the contractor.
Yes.
So they don't pay for, I don't want to say it's just stupidity, but like if you don't do something right, the insurance company doesn't want to pay the bill because you didn't do it right, right? So workmanship is excluded on most insurance policies. So here my client is the chiropractor who now went back to their contractor who installed the windows. Their contractor went to their insurance company. Insurance company declined the claim. My chiropractor client wanted to file a claim. Their claim got declined because it was pre-existing or something. I forget the reason for denial, but it was a mess. And so I guess back to the installation of this product, I think you said that, let me grab it real quick. So if this is the exterior right here,
Yes.
where the grooves are, this slot should be spray foamed.
Correct.
And then out here we would have poly, right?
Nope.
No. Well, how do you get the cellulose in there to stay?
Oh, netting.
Netting.
Yeah.
Oh, okay.
Yeah, cellulose. You can do dense pack, then you don't need the netting.
Oh, okay.
But generally, you're probably just going to have netting to hold the cellulose in place.
And that's that blown in?
Yeah.
Yeah. Okay.
Even dense pack is blown in. It's just because there's multiple ways to do cellulose. There's wet pack, there's dense pack, there's blown in. Yeah.
Okay. Awesome.
But when you use that, the foam on this outer edge, that becomes, if you do at least an inch, that becomes your vapor barrier. So now we don't need the vapor barrier on the inside. We don't need vapor boxes. We don't need sealants. We don't need the plastic vapor barrier. A lot of stuff that adds extra cost now you don't need. And the big thing is your wall can breathe to the inside of the house. There's a reason why houses from the 1700s are still standing.
Mhm.
They're not very energy efficient, but they breathe.
Right.
That's the key, is they breathe. When we started doing the new energy codes about 1980, we started limiting the ability of the walls to breathe, and that's where we started running into exactly what your
Rot.
chiropractor friend had.
Yeah.
With the spray foam here, now this wall system can dry to the inside and it can dry to the outside because we've given it the ability to. That's the resilience issue. That's why we were out in DC at the HUD showcase.
So let's say I'm a manufacturer and I have a CNC machine. I'm like, okay, cool. Let's do it. What would be a good prospective manufacturer that would partner well with EcoSmart?
It's going to be somebody that's used to making customized lines. So this would be a custom. You could do it with off-the-shelf hardware if you wanted to, but to really get your costs down and get your output up, it's going to be a custom machine. Which, if you're used to that, which there's many companies across the country that are, I can think of a couple off the top of my head that I've talked to. It's a relatively straightforward design, a little tinkering around, and that's why we have a production specialist. Just the fastest way to get wood through and cut it, the most efficient way. And you're just, you're looking at, a specialized line that can kick out, millions of studs a year. And that's what you need to do, obviously, to keep your production costs down, because then you're talking about, manufacturing costs of under $1.
Okay.
Which by far puts us in the insulatable stud category as the least expensive option, because we're not manufacturing a truss, a wall truss.
Or a laminated beam.
Or laminated beam. We're not putting foam in between two 2x2s. There's a couple competitors out there. I pick this way because we're using the known strength of the wood. This is 2 to 3 times stronger than a 2x4. That's all we need to build a house is a 2x4. We have the depth for the insulation. We have the strength still using the wood. So we're not counting on anything else. It's still the properties of the wood, which is tried and true over hundreds of years.
So this 2x6 with the slots and the grooves cut into it, did you say it's still stronger, 2 to 3 times stronger than a standard 2x4?
Yep.
Wow.
Yeah.
Because that would be a concern of mine, I guess, not knowing much, outsider looking in, and my house is going to be built with 2x6s on the exterior with these holes cut into the studs,
Mm-hmm. Yeah, there's basically, for houses stresses, there's 2 types. It's compression, and then the other one is racking. So compression is the stepping on the soda can,
Mhm.
And houses basically don't fall down from that because 2x4s are incredibly strong. The amount of pressure you can put on a 2x4 before it cracks is enormous. So by keeping this the way it is, we keep the structural integrity, okay? So then the other force is what they call racking, and that's when the tornado comes by, the hurricane comes by, the earthquake shakes the ground, and the wall tries to do this. That's
Okay.
racking, and when it shakes back and forth. Yeah. That's where the spray foam comes in. We use a standard nailing pattern, and our nailing pattern is just slightly under what you would consider average for racking. Just a little bit under it, because we have some nails that don't have solid contact with the sheathing. But once you put the spray foam in there, that changes the whole game.
Yeah.
Because now, instead of having that physical one point attachment of that nail, that single nail head, now we've glued the whole thing together. And that's why I said, now from here, we're racking as normally, now we're up here because we've completely glued the assembly and reinforced it with steel nails.
Okay.
So that's why, if you're, like I said, if you're going to expend embodied carbon, structurally reinforce, vapor seal, air seal, and then finally insulate. That spray foam is a really good product, period. Just use it wisely and get your bang for your buck.
Yeah. Okay. So I'd like to go over to your slide deck here. And if there's anything you want to comment on as I'm scrolling through here. And again, this will be available on YouTube. And so what do we got going on here?
Well,
Anything?
we covered all that.
Okay.
We covered that. Yep.
It's patented.
Comparison. Yeah, the first thing I did was patent it.
Yeah, good idea. Here's a cross section of the spray foam, right?
Yep, you can see this one, there's 3 inches of spray foam in, and that shows how, and again, it's up to the individual. You need 1 inch for code. Well, no, okay, take that back. You don't necessarily need 1 inch for code, but if you want to get your most strength, in that case, it's about 3 inches because now your stud is completely embedded in that foam. It's going nowhere. So
here's the OSB.
Yep.
What's this layer right here?
Foam, spray
That's
foam. Then you have the wood.
Oh, that's where a groove is.
Yeah, that's where a groove is. And then you have the wood, and then you have the foam again in the slot.
So here's another view of it where you can see where the grooves are and the slots are and where the exterior OSB is.
So we're guessing for down like in Florida. Florida has its own set of codes. You might wind up with a little more spray foam in the chamber, but in the end, then you might not need any backfill cellulose.
Oh, you use it for the bottom and top plates too, huh?
You can. Right now, we're not stressing that, but when I shot this picture, you can.
Okay.
That's down the road. And that's the example of how you're disrupting thermal bridging.
So this is the typical?
Yep, that's a typical wall.
And here's yours.
At 0 degrees outside and 69 degrees inside.
And you can see the cold coming in through the typical standard studs.
Yep, that is the purple studs. That is thermal bridging, the temperature difference, because the energy passes through there and lowers the temperature of the stud. Our test wall, it was really hard to shoot that picture because there's just no difference in the temperature. Yeah. And that's what you want.
Yeah. No new training, speeds up the building process.
Yep.
Electrical wire, I mean, the holes are already drilled.
Yeah, one of the vice presidents at the Structural Building Components Association said that we were really unusual because we're actually trying to make the process simpler for all the guys.
Yeah.
Everybody else is always trying to add that next gadget, that next whatever to the process. We're trying to actually take steps out.
Okay. Yeah, good. Creating a more efficient home, saving energy and money. 25 to 62% reduction in energy bills depending on the wall assembly. That's substantial.
Oh yeah. No, you can with the 2x8 in leaving the money on the table for the triple pane windows, and there's some really cool vac windows coming down the line. You're talking 75, 80% reduction in energy use, which then makes your solar array really manageable.
Now, you made a point earlier, too, that, I mean, your energy use isn't just dependent on the insulation value of your wall, because you also got to, turn your lights on and turn the TV on and dry your hair type thing.
Yes.
So, but is this an overall reduction in the total energy bill, like 25 to 62%? So, for example, like I just sold this big old house. Insulation was not worth a shit. And I think I was paying between $400 to $500 a month for my electric bill. $400 to $500 a month. So
wow,
right? Crazy.
That's crazy.
Yeah. So by using this product, would I expect to cut that in half?
That is HVAC energy use.
HVAC. Okay.
And the idea is we want to get that usage down to as small as possible.
Yeah.
Because then you can power your whole house depending on how much energy you're using. But 7.75 kilowatt array is pretty typical around here. Runs about $20,000 retail. Payback, return on investment, 7 to 9 years.
Okay.
And then you're free and clear for
Okay.
25 years, 30 years.
Then you're making money.
Yeah. My array's almost paid for.
Nice. Reduced weight. You threw out this 5 million pound number, I think, earlier. So
Yes.
imagine a train full of EcoSmart studs versus the standard studs, right?
Correct.
And the weight of the train would
Yes.
be 5 million pounds lighter,
5 million pounds later. Because
which reduces transportation costs. It's good for the earth.
Yep.
All that stuff.
yeah, the diesel locomotive's gonna burn far less diesel. When they switch over to electric, they use far less kilowatts, which means they don't have to recharge as often.
Yeah.
So it's either way, it's a benefit. And then you have lower freight costs because you pay per ton mile.
Okay.
And each rail car is multiple, I forget how many tons, but I use 5 million pounds and I've used 5 million pounds instead of tons, and now I got to do the backward math, and that's not happening right now.
Okay. All right. Creating material for additional uses. Yeah. So let's say, I don't know if this is referring to that, but all that material you cut out of here, and I think you said it removes like a third, right? A third of the material from the stud is now gone, but we don't need it.
Don't need it.
So what happens to that third?
That gets reused for about whatever other product you want to. It can be used in bioplastic. It could be used for animal bedding. It could be used to make other trim boards, things like that. There's lots of uses for that product, and it just makes more sense. It's like, well, it's just costing the homeowner money. It's just costing you money to transport it.
You don't need it.
You don't need it. Take it out at the start, get all the benefits down the road, and sell it off for something else. So it's another product for the mill now to sell, or the manufacturing facility to sell.
Yeah. Awesome. If you see anything that you want to touch on, let me know.
Well, we went over the upgrade cost. That was the big thing is now the 2021 Energy Code. So that's the list. Washington State, Vermont, Connecticut, New Jersey, Rhode Island have adopted the 2021 Energy Code. Minnesota has opened up the debate again this year to adopt it or just adopt the 2024 code next year. But one of the reasons the Energy Code is being so slowly adopted across the country is due to cost, and that's what the cost implications slide is for from the Washington Builders Association. They came up with basically the same numbers that I did 5 years ago. The tax credit that you talk about on that slide is $2,500. So you add $2,500 back to $9,200, we're at $11,700. When I did my math 5 years ago, I was at about $11,600 in upgrade cost. If my studs were available back then, it would have cost me about $3,500. That's a dramatic lower cost.
Okay. So let me get this right. So if today I'm building a house in Minnesota, and if Minnesota adopted the 2021 Energy Code and I had to abide by that code, it's going to cost me about $11,000 more to build that house.
Correct.
Right. But with your product now in the mix, it's not going to cost $11,000 more to meet those code requirements, but only about $3,000.
Yeah, $3,000 to $4,000. It kind of depends on where the pricing on the stud winds up.
Yeah.
But the other thing is how much spray foam you have to put in the chamber, because the spray foam is the most expensive part of the equation.
Okay.
The stud isn't. The stud's actually, when you look at cost savings, is a wash, because the stud upgrade in that number I just threw out there is about $1,500.
Yeah.
Well, we figure there's $1,000 to $2,000 in labor savings for the contractor. So technically, there's no
additional.
cost.
Yeah.
No, it's just how much spray foam you have to put in the chamber.
Okay.
I forgot about that slide. That's the Saving the World slide with all the reduction in CO2 and energy across between now and 2050.
Okay. Testing.
Testing's all done. It's fun to break studs. And that's just one of our slogans. Saving the world is just good business.
Yes, it is. And there you are, Jon.
Yep. And the other co-founders and some of our consultants and our production specialists.
Now, one thing I also wanted to touch on, some of my manufacturing clients have gotten to this point. A lot of them want to get to this point where they're doing a lot of contract work where they're manufacturing a piece of something for a price, and then they work with somebody else and make something else. They're not making much of any of their own products that they're selling directly.
Okay.
And can you talk about a little bit what this whole process has been like for you as far as the invention piece? You come up with the idea to where you are now, starting production out in Washington.
The big thing was coming up with the idea was just solving a problem. I'm a builder. And I have the unique thing is that I design and build. And I ran into a very expensive problem and just went, there's got to be a better way to do it. Came up with a better way to do it, got a patent, got my IP protection. But then it becomes the question of manufacturing. I originally was planning to manufacture this, and that's why we have a production specialist. We had it all figured out to do it, just use off-the-shelf hardware to start production, and we could, manufacture 500,000 studs a year with off-the-shelf CNC machines. Mike's very bright. He had figured out how we were going to do it. Low cost to set up, but we always knew that, you're talking about hundreds of millions, if not billions of studs across the country. That was never going to be the final solution. It was going to be dedicated lines to just producing this.
Yeah.
And that's where the decision was made when I brought on co-founders that we were just going to stick to the licensing model and then have other people. It's almost technically the franchising model. It's just a faster way to spread out across the country quicker. Because one, it works better. It works for us, but if, again, for 2030, 2050 climate goals, again, the faster this spreads out, the lower the amount of carbon that's going into the air, better for everybody.
Yeah.
So we have benefits from the framer to society. So we cover everybody in between. I care about the framer too.
Yeah.
Because I'm one of those guys.
Yeah. All right. So I'm a manufacturing guy and I have some experience in custom machining. Would you recommend that I go out and try to find a mill that's willing to partner with me? Or do you have any insight, or would they contact you? What's the best way to go about things for that guy who might be interested in getting involved in this process?
Contact us, because I have made some really good contacts at some of the larger mills around the country. And it just depends on where that mill's at. Like out in Washington, there's multiple places that produce cross-laminated timber. So they have the on-hand manufacturing experience to make these studs. They know how to do it.
Yeah.
Around more towards the central part and the east part of the country, that's not the case. They're just cutting lumber. But when you talk to the mills, they're more than happy to supply you the lumber if you want to come and build right next to them, because that's the most cost-efficient way to do it. There's usually land available, like up here, up north. They're right on rail spurs, so you can access their distribution channels. So we've kind of already got this all worked out.
How big of a plant do you think it would take to build next to a mill to make this efficient?
It depends on how many studs you want to manufacture, is what I've been told. So anywhere from, I'm trying to think of what Mike told me.
Where's Mike?
Mike Bruce. Oh,
where is he?
Yeah, I just don't want to quote wrong sizes, but I want to say 200,000 square foot facility, and that's more than enough room to get in there, and you're producing, tens of millions of studs, which that's not even enough for the Minnesota market. That's like even out in Washington, we figure that market alone per year is 20 million plus, and it's probably closer to 40, 50. But I prefer to be conservative on my numbers.
So the state of Washington consumes about 40 million studs a year.
Yeah, we build about 1.4 million single-family homes across the U.S. each year. And we build 200 plus thousand multifamily units. When you get into multifamily, then the stud count goes through the roof.
Yeah.
And that's why across the country, you're talking about easily 1 billion studs. And that's just the U.S. market, haven't included Canada, Europe, South America, or Australia.
Okay.
Those are all areas that do with light frame construction is what it's called.
Okay. Cool. Well, what else? Is there anything else I should touch on before we wrap this thing up?
No, I think you've done a good job of covering everything. It
All
made me
right.
think about some stuff.
All right. I got tough questions, man. So, is it okay if I give out your contact information?
Yes.
All right. His
Feel
name
free.
is Jon Pues, Jon, and there's no H in his first name. Last name is spelled Puis. We're gonna put this stuff in the notes section of the podcast also. John's phone number is 612-887-5200. Again, that's 612-887-5200. Email address is johnp@eco, that's ECO, smartstud.com, and check out their website, EcoSmartStud.com. It looks like you're on Facebook, Instagram, and LinkedIn. And yeah, I appreciate your time, Jon. This is a very, smart product, right?
I'd like to think so.
Smart. It seems
It's low
easy.
tech.
Yeah, it seems easy. It's like, why didn't somebody think of this 50 years ago?
And actually, the question you kind of brought up earlier, I had a student ask me down at the U of M. It's like, well, this is so simple. Why didn't somebody come up with it before? And I'm like, I don't know. I just know I came up with it and patented it.
Good for you, man.
And when we went to patent it, my patent attorney went, I've never had this happen in all the years that I've been a patent attorney. I'm like, what? He goes, we got 99% of everything we were asking for on the first run, which means no one has ever tried to patent this before. I'm
Crazy.
like, okay, cool. Because it's like, it makes sense.
Yeah.
At least it makes sense to me.
Yeah, it does to me too. All right, guys. Thanks for listening. Have a good one.
Thanks for listening to the American Made Podcast. Want to be a guest on American Made or know someone who should be? Apply online at theamericanmadepodcast.com. Don't forget to like and subscribe on your favorite podcast app to be notified when new episodes become available. And we'll see you next time on American Made.